Hey, 7th graders, you need your 3.1a comparing rational numbers notes out in front of you, a pencil, and a calculator. Pause the video if you need to. As a reminder, pause the video anytime that you need to finish writing things down, to rewind, rehear something. That's a great reminder. Today we're going to be comparing rational numbers. We know rational numbers are numbers that when we divide them, we get a decimal that stops, it terminates, or we get a decimal that has a pattern. It has repeating digits or a repeating digit. Remember our comparing symbols. These are the three that we're going to be using. The greater than symbol, if you're not comfortable with these symbols, write them down and label them. Equal to and the less than symbol. So when we're comparing values, we're looking at each place and the value within that place. So knowing our place value system is really helpful. Our goal is I can compare positive and negative rational numbers. So the one thing that's new for you this year with this lesson is the negative rational numbers part. Last year, if you were with us in 6th grade, we did the same lesson. We just compared positive rational numbers. So you need to write these two examples down in the appropriate box in your notes. We are in example 1 comparing 7/10 to 3/4, and in example 2 comparing 1 68/100 to a -1 1/4. Our question as we're working through this lesson today is, how do we compare these rational numbers? How do we do this? I'm seeing 1 as a decimal, 1 as a fraction in number 1. It's hard to compare when they're in those different forms. So let's change them to be in the same form. In my opinion, I find it easier to compare numbers when they are in decimal form. So on the left-hand side in your notes, next to that first star, write this down. Convert to decimals. Change these rational numbers to decimals and compare each place and value. And when we're converting them, we're bringing back some knowledge from Unit 2. 7/10 is already a decimal. So let's go ahead and let's change 3/4 to a decimal. And you might go, Miss Claver, I already know what 3/4 is a decimal. Awesome, write it down. Here's a reminder. We go numerator, which is 3, divided by denominator, which is 4. We get 75/100. So I'm gonna stack my decimals on top of each other because I wanna compare each place and the value in that place. You'll see that I added a 0 to my 7/10. This is that annex 0. I like to make my decimals the same length as well. I find that helpful. So if I go to the ones room, they're both zeros. I can't compare yet. If I go to the tenths room, they're both 7s. I can't compare yet. If I go to the hundredths room, here I have a 0, here I have a 5. Which one is smaller? The 0. So that means 7/10 is smaller than 75/100, which was 3/4. So I'm going to use the less than symbol. Remember, we read from left to right when we're using these comparing symbols. Let's go to the next problem. 1 68/100, we're going to compare that to a -1 1/4. If you didn't write it down yet, pause the video and do that. What do you notice in this second problem here? That minus sign. Let's go off to the left-hand column in our notes and let's write this. When a negative is compared to a positive, or vice versa, if a positive is compared to a negative, the positive is going to be larger, right? I don't even really need to change these values into decimals here, or the 1 1/4 into a decimal, but I will. And remember, when it comes to changing a mixed number into a decimal, just ignore the whole number part, and on your calculator you would go, I'm going to ignore the minus right now, 1 divided by 4, and you'd see that that's 25/100. So if I put it all together, it would be a -1 25/100. And we know our negative is going to have a smaller value than our positive. So since I read from left to right, I'm going to say 1 68/100 is greater than -1 1/4. Let's go to the next two examples. We're going to take it to that next level here very, very soon. I just want to give you a friendly reminder. What happens? You see my number line here. It's increasing by 1s or decreasing by 1s. What happens to the value of numbers as you move to the right? Yeah, they increase in value. The flip side of that, what happens when we move to the left on a number line? They decrease in value. So keep that in mind because now we're going to take it to that 7th grade level. Let's do example 3 and example 4. Go ahead and write these down. So we're comparing -39/4 to the -square root of 25. So again, I like to see rational numbers when I'm comparing them, whether they're positive or negative. I like to see them in a decimal form. So I'm gonna change negative 39/4 into a decimal. When I enter it in my calculator, I'm just gonna ignore the minus sign right now. I'm gonna go 39 divided by 4. It's an improper fraction, so I know there are gonna be whole pieces to my decimal here. I get 9 and 75/100. This is going to be a negative 9 and 75/100 because of this minus sign out front. Now I'm going to use my number line up here just to kind of help you since we're comparing two negative values. I'm going to plot negative 9 and 75/100. Here's 0. Look up at the number line. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Negative 9 and 75/100 is going to be closer to negative 10 than it is negative 9. So you can see it right there. Now, if I go to my other rational number here in my problem, it's the negative square root of 25. Entering that in my calculator, I'm just going to ignore the minus sign right now. I'm going to hit my second key. I'm going to hit the square root sign, which is right there. It's on the squared button. 25. Now, this is a perfect square. So if you already know what the answer is, awesome. Remember, you're thinking, what times what? Same number gives me 25. 5. It's going to be a negative 5, though, right? Because we have that minus sign right there. So negative 5, notice I added 2 annex zeros here just to make my decimals the same length. I'm going to plot negative 5 on my number line, which would be right there. Now, remember, as we move to the left on number lines, values decrease, right? So really when I look at this, I'm going to see that negative 9 and 75/100 is more negative than negative 5. Let's put that on the left-hand side of our notes. Look to see which one is more negative. It's going to have the smaller value. You're so used to seeing a 9 and a 5 and going, 9 is bigger. But this is a negative 9 and 75/100, and this is a negative 5. So really here, negative 9 is more negative. Negative 9 and 75/100 is more negative. It has a smaller value. So negative 39/4 is less than negative square root of 25. Let's look at the next example. If you didn't write it down yet, pause the video and write it down. We're going to compare negative 10/3 to negative 3 and 75/100. Let's start by changing negative 10/3 into a decimal. I'm going to ignore the minus sign. I'm just going to go 10 divided by 3. I know I'm going to get a whole number, right? Because my numerator is larger than my denominator. It's an improper fraction. 3.333333333. That 3 is going to continue on forever. So when I write this as a decimal, I just want to have at least 2 3s because I can see my 75/100 over here in my second rational number goes out 2 digits. So I'm going to write that down. Negative 3 and 30 and 3/10 repeating. This 3 is going to go on forever. I just did 2 of them though, and I'm comparing that to negative 3 and 75/100. Let's go to each room and compare our values. So in the ones room we have 3s, both negative. Can I compare yet? No. Let's go to the tens room. Here's a negative 3/10. Here's a negative 7/10. Now let's plot these two values because right now we can tell, right? We have a 3 and we have 7, a negative 3 and a negative 7. We can compare those. I'm going to plot them on the number line to help us see it. Negative 3 and 3/10 repeating, so 0.3. Here's negative 3. It's going to be to the left of negative 3, about right there. And then negative 3 and 75/100, again, is going to be to the left of negative 3, but it's going to be closer to negative 4, about right there. Which one is more negative, the red or the pink? The pink. 3 and 75/100 is more negative. It's further left than negative 10/3, which I did my estimated value right there. So that means negative 10/3, since it's closer to 0, right, but still on the left side of it, it's larger than negative 3 and 75/100. Remember, we have to switch our thinking. I'm going to go to the tens place here. You're so used to seeing a 3 and a 7 and going, a 7 is bigger. But this is a negative 3/10. This is a negative 7/10. That's more negative. The 7/10 there. Let's look at the next two examples in our notes. Go ahead and write down example 5 and example 6. We have negative 9/10 and we're comparing that to negative 4/5. And for example 6, a negative 5/9 and we're comparing that to negative 5/10 repeating, or 0.5 repeating. So again, I like to see my rational numbers as decimals. So for example 5, I have my 9/10, negative 9/10, that's a decimal. So I'm going to change negative 4/5 to a decimal. Ignoring the negative, I'm going to go 4 divided by 5. 8/10. So this is going to be a minus 8/10. So negative 9/10, and I'm comparing that to negative 8/10. I have the same number of digits in each one of my decimals here, so I'm going to go to each room and compare the value there. Here's the ones room. They're both zeros. Here's the tenths room. It's a negative 9/10, a negative 8/10. So I'm going to plot them on the number line. I know you don't have one in your notes. Just look, though. 0 to negative 1, that makes up a whole, right? Just like 0 to positive 1 would make up a whole. How many equal pieces is my whole cut up into? Well, let's count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means this is negative 1/10, negative 2/10, negative 3/10, negative 4/10, negative 5/10, negative 6/10, negative 7/10, negative 8/10, negative 9/10. Which one is more negative, the orange or the pink? The orange is. Negative 9/10 is more negative than negative 8/10. If it's more negative, it has a smaller value. So reading from left to right, negative 9/10 is less than negative 4/5. Our last one here, negative 5/9, and we need to compare that to negative 0.5 repeating. Let's start by changing negative 5/9 to a decimal. I'm going to go 5 divided by 9, 0.5555555, and my calculator screen isn't that big, so it's rounding up this last digit, which would have been a 5, but it's rounding it up one more to a 6. So this 5, it tells me, is going to repeat forever. So when I write that as my decimal, it's going to be negative 5/10 repeating, or negative 0.5 repeating. Whoa, wait a second. This one right here is negative 0.5 repeating, right? This 5 is going to go on forever. You'll notice I just did 3 of the digits in each number, but they're both going to repeat 5s forever. Negative 5/9 and negative 5/10 repeating, they're the exact same value, so they are equivalent to each other. They are equal to. Let's do our last problem. Team A won 6 out of 7 games. Team B won 7 out of 9 games. Which team won the higher fraction of games? We're still comparing rational numbers here. We need to figure out which team won the higher fraction, the fraction that has the greater value. So blank team won a higher fraction of games. Marking the text is a great strategy. Whether you know how to solve the story problem right away or you don't, it's a great strategy. I'm going to go line by line and now look for key operation words. Anytime you need to pause the video, do so. Team A won 6 out of 7 games. Out of, that's a division word or division phrase. Team B won 7 out of 9 games. Which team won the higher fraction of games? So I'm going to leave these values, these division problems, in fraction form. Well, Team A, I need to know how many they won compared to their total number of games. So that would be 6 to 7 total games. Team B, I need to know how many they won. That number is 7. And they played a total of 9 games. So now I can set this up. I'm comparing 6 7s to 7 9s. I am going to change these. They're both in fraction form. Again, I like to compare rational numbers when they're in decimal form. It's just easier for me. So I'm going to take and I'm going to change 6 7s to a decimal. Okay. 0.857142, 857142, 857142. As 7 9ths, I'm going to change that to a decimal. That 7 is going to repeat forever, right? It's just rounding up that last digit that my screen can fit up to an 8. So I'm going to put those 2 decimals here. And if I look at the first place here, which is the ones place, they're both zeros. So if I move to the tens place, I have an 8 in the tens place here. I have a 7 in the tens place here. These are both positive. So 8 tenths is more positive than 7 tenths. That means this one has a higher value, this one being 6 7ths. So 6 7ths is greater than 7 9ths. Do you remember which team won 6 out of 7 games? Team A did. So A team won a higher fraction of games. Today we worked on comparing positive and negative rational numbers. The new part for you is comparing those negative rational numbers and changing your thinking, meaning if a number is more negative, it has a smaller value. Have a great rest of your day.